Those using Python, I'm going to go through what I had done for the Java folk in class today. Okay, so and all of this is augmenting what was discussed in class, so it's not independent of that. But I'm just going to go through the Python implementation of it. And so the first thing was turning off the kind of overriding the fact that the simplest referee had been scheduling the detections, which I did that so that we could at least sort of see the sensor in action. But as mentioned in class, that's not the ideal way to be doing it. So the first thing is that simple referee, which I still want to stick around. So it's like I don't want, and one of the benefits of object-oriented design is that you can reuse what's been done and just sort of fix the things that you need. And so this is what the simplest referee 2 looks like. It's completely overriding the enter range and exit range events in the superclass. And now in the event graph model, it's scheduling an enter range with arguments that are the sensor and the target, and likewise for the exit range. Now in Python, unfortunately, you can't do that. This is my complaint about, in Java, this is called method overloading, where you can have more than one method of the same name. As long as they have different arguments, then that is fine. Python does not support that, which is one of the reasons why Python is not truly an object-oriented language. It has some of the characteristics of object-oriented languages, but it's not really truly object-oriented. Basically, they bolted objects on in a very crude way, in my opinion. But again, Python's popular. A lot of people use it. A lot of people like it, and so that's what it is. All right. So one of the consequences is you literally cannot do this in Python. So what we're going to do is we're going to just have these enter range events with the sensor and the target as arguments. We're going to call them enter range with an underscore at the end. So let's take a look at what that looks like. So here's our simplest referee 2. It's subclassing our simplest referee. So we have our constructor, have the target and the sensor, and we're just going to call the superclass the simplest referee constructor, passing those to it. And there are no state variables or other parameters. The other thing is that in the superclass, the sensor was listening to the simplest referee, and that was necessary so that the sensor could hear those detection events. But we don't want that here. We don't want the sensor listening to the referee. I mean, it's not that it's going to do any harm, but it's not necessary, and we can do it by removing the simplest referee in this 2 in this case as a sim event listener, and that's how we do it. So we're okay. So here's how we do the enter range. So here's the enter range event. And now, fortunately, Python does support overriding. That's what this is. This is overriding. In other words, we're replacing the enter range event in the superclass. And again, we needed this, well, maybe if there's only one referee running around, then it's not so much an issue. But if we were using more than one referee, which we can do in this case, then that would be necessary. Okay. So what are we doing? We're scheduling an enter range, and then notice that it's got a little underscore there. If you don't put the underscore, what's going to happen is that Python's going to choke. Why? Because it already has an enter range event that doesn't have a sensor and a target as its argument. So we're going to schedule the one with an underscore, and so that'll kind of work. Then we do need to schedule the exit range time and if the exit range event, And note, this is the one in the superclass. See, that's still there. So we are going to schedule that. And so that's going to, that's actually going to call this one. And then this is going to call an exit, schedule an exit range, again with an underscore. That's kind of the difference. So here the exit range is doing this for that. All right. Now, there were three mediators that I've been talking about, and these more or less match the three mediators in the more complex model that is going to be in the assignment. So let's look at the simplest cookie cutter mediator. So for the mediators, what we're looking at is we're actually implementing the enter range event with the sensor and the target as its arguments, and we are scheduling a detection with a delay of the time of detection, and we're passing the target, which we have received from the enter range event, and we're actually, this edge actually is being scheduled on the sensor itself. I'll show you how that works. So here's our simplest cookie cutter mediator. It has no parameters. And so here's the enter range. We schedule our detection event. Notice enter range with an underscore, so we're going to hear that underscore one. And when we hear that, we're going to schedule a detection. Now notice it's on the sensor. So we say sensor schedule, detection, cookie cutter says 0 delay, and then the target. And then for the exit range, likewise, again, notice the underscore. We schedule an undetection on the sensor with the target. So how would we, let's kind of test this. Simplest cookie cutter mediator. So how do we set that up? Well, we have our simplest mover, and here we'll have our simplest path mover manager. We're using the same idea here. And so for the mover managers, we need to kind of futz with that. Here's the mover we have for our sensor, and we're giving it goose eggs across the board, so it can't move even if it wanted to, but we're giving it a range of 20. And then here's our referee. We give it this target and this sensor. Here we instantiate the mediator, and then add it as a sim event listener to the simplest referee, which is simplest referee 2, which is what the diagram says. And then we're going to sort of dump all the state transitions, and then we just kind of run it in verbose mode. And when we do that, we see that again, like always, do a describe on these guys, and just make sure that we are passing the parameters correctly. So we got the path there. Our sensor has a range of 20, I mean. And then here's our referee, and it has the 2 guys there. And so after we spin through all the run events, the path mover manager says next waypoint. That causes a move to. And then move to schedules the start move. And then now notice that when the start move happens, and that was on the simplest mover, that was heard by the referee, and the simplest referee, and that scheduled the range one. And so the schedule range, if you notice, we see the times here. So when it solved the equation, we got two positive roots, and so it's going to schedule the enter range at the lower time, and then it's going to schedule the exit range at the second time when the enter range occurs. Now here's the enter range. Here it's scheduling the enter range with the underscore, and here's the underscore one. So even though this was heard by the mediator, so it's not going to be listed anywhere, but here notice that it's scheduled the detection on the simplest sensor. And so there it is, and we see that the target was detected. And if you carry that through, that you see that that all worked. Okay, so and this should be exactly the same as for the simplest referee, is what that was. Okay, now let's look at the next one, which is the constant. The constant time mediator, and for that there's a fixed delay between enter and exit. So we have a parameter that's delay time. Well, you can call it whatever you want, but we're calling it delay time here. And so we set that in our, that's going to be a parameter. And we want to make sure that it's not less than 0, because that causes lots of problems. So basically the same thing here. So we have an enter range underscore. That's going to schedule a detection with the delay of the delay time. Now, as mentioned when we look at the exit range, again with the underscore, the same issue applies. And this was discussed in class, but just to go through it again, if we have detected the target, if the sensor has detected the target, then we schedule the undetection. How can we tell if the sensor has detected the target? We can say if the target is in the sensor's contacts, then that means it's detected it, so we have to schedule the undetection. But if it's not in the target, if it's not in the sensor's contacts, then we need to cancel the detection for that target. Okay, so all right, so let's test that. So let's here with the constant time. So here's kind of the same thing there, and so here we're instantiating it. Okay, there's the referee, and then we're gonna start with a delay of 0.5, because what that's going to do is well, let's run it and see what happens. So now our delay is going to be 0.5. We need to make, and I do a describe on the mediator to make sure that we've actually gotten the right delay time. And so everything is more or less the same until we have an enter range event. And so here the enter range, the original enter range event is going to schedule the enter range underscore. Okay, so the underscore one is heard by the mediator, and notice that 0.84 plus 0.5 is 0.13, so it schedules the detection after that delay. And then we see in the exit range that it has to schedule the undetection because it was actually detected. And now what we want to do is we want to make sure that if it hasn't detected it, that interrupt is working right. So we change the delay to 1, and now we see, okay, everything's the same. Enter range detection. Let's see, where is it? Yeah. So here, notice that the exit range is scheduled before the detection. So what we're looking for is, will the exit range cancel the detection? And we see when it occurs, there's no detection on the event list, so that has worked. So let's roll back all this. And then the final one is the constant rate. So what the constant rate is that the delay, the time to detection is actually an exponential distribution with a mean of a certain value. And the way we're doing that is we're going to have we're going to have an instance variable that's an exponential mean with a mean of 1, and we're going to multiply our mean delay. Oops, I see this should be, Oh, so I guess that was right after all. I called it delay. Well, I call it this. I'm going to refactor this. This should be called the mean delay. Okay, so I'll update. I'll push that when I'm done here. Okay, so the it's that mean delay times the exponential, and as I mentioned in class, you can't do this for every probability distribution, but for some you can. And in the case of exponential, it's one of the ones where you actually can. So we're going to schedule the detection with that delay. So we're going to get some funny number, and then the exit range has the same issue. So exit range is scheduling undetection with a 0 delay period, or it's canceling the detection if we haven't detected it yet. So here, let's test that. So everything is the same except for our constant rate mediator with a, okay, we have different delays here. So let's start with the smaller delay. The smaller mean, now this is the mean delay actually. So let me call it by its proper name. Oops. Okay, so there's the mean delay, and then see how that goes. There, so the mean delay is 0.5, and then it'll print the exponential generator as well, because we define that to be a parameter. And so we run up to the enter range stuff. Okay, schedule, we have an enter range, again at the same time. And now the enter range of the mediator is going to schedule the detection at 1.2. If you remember before, it was when we simply added 0.5, it was like 1.3, but here it generated the exponential, and then the detection, and then the exit range has the undetection. Okay, so that's a check, but if we now crank our mean delay up to 2, it turns out that let's sort of verify that we actually got the 2 in. There it is. And okay, here we have the enter range. And we see now that the detection is scheduled at, say, 2.5 times, which is not only after the exit range, it's even after the end move. So that detection is kind of way out there. And so now what we're looking for here, the exit range, cancel the detection. So end of story on that. So that is the Python simplest ones. And what you'll be asked to do next week is kind of do all that, but adding on to the simple mover and simple path mover manager stuff that you're doing this week. So that's what that is.